Excited to have Riccardo Spagni in today for our Code School guest speaker. He's a Monero core developer, and he's very active in the Monero community, and he's continually researching new technologies in order to improve upon Monero. So please give a warm welcome to Riccardo.
So, hey everyone. I'm going to talk to you today about Monero and privacy in general. As mentioned, I'm Riccardo Spagni. You may know me as Fluffy Pony, or that giant troll on Twitter. And I'm going to talk a little bit about why privacy matters, what Monero does, what other attempts have been at privacy, Monero's birth and growth, what we're doing to make Monero useful and usable, and the future of Monero. So, the first thing, and the thing that a lot of people misunderstand when we're talking about privacy, is that it's not just about buying drugs. There are other things that you can use privacy for, and financial privacy in particular. Obviously, if we don't have financial privacy, there are bad things that can happen, like we might end up with targeted advertising, so based on our spending habits. Also, targeted crime against the wealthy. You go and do a local Bitcoins exchange, and next minute you're held up at knife point. Or even worse, you go and pay with Bitcoin for something, and now the guy knows your bank balance. Unintended leaking of sorted purchases. Do you really want everyone at the office knowing what you've purchased? I, for one, don't. Unwitting complicity in criminal acts, and this is something that could happen if, for example, you're using a tumbler, and now you end up with dirty coins, and next minute you deposit it at Coinbase, and Coinbase close your account. That's never happened before. And next minute you're kicking up a storm on Reddit. And then, of course, there's minor censorship, so miners can censor transactions based on what they view as spam or bad recipients or whatever. It can reveal sensitive business relationships, and it can also leak salaries, profit margins, and revenue, all of which are terrible things to have leaked. But of course, the larger issue is that most people don't care yet. And this is from a Pew Research study in 2014, Public Perceptions of Privacy and Security in the Post-Snowden Era. And they asked people what they viewed as very sensitive in terms of information. So their social security number, oh no, well, you know, it's 90% viewed that as super sensitive. The medications they take, 55%. The content of their emails, 52%. Their religious views, 22%. Their friends and what they like, 22%. Basic purchasing habits, 8%. Apparently nobody cares. But that is changing, and there's a comment I found on Reddit a little while ago, Bitcoin, which really shows that Bitcoiners are among the first to realize the need for financial privacy. And this guy said electronic cash is easy. Facebook could do it. Private electronic cash is harder, but David Chaum did it in the 90s. Decentralized electronic cash is even harder, but, you know, we all know what Bitcoin is, and we've already solved that problem. And, of course, decentralized private electronic cash is the hardest thing of all, and that's the thing that really what we will kind of like the next step that we need. So, knowing that, what attempts have been made at transactional privacy, especially within Bitcoin? And there have been a bunch of them. The most common one, of course, is mixing, and that's kind of bad because you end up sending it to a centralized tumbler. They steal your coins, or they claim that they don't steal your coins, and of course the risk is just way too high. CoinJoin is better than that because you can be done in a decentralized manner with Join Market, for example, but with that you run into liquidity problems, you run into Sybil attack problems. Mimblewimble is a fantastic scalability enhancement for Bitcoin that can be enabled as a sidechain once we figure out how to do sidechains trustlessly. But the privacy enhancements of Mimblewimble basically assume that you're throwing away transactional history, which is not entirely the case. Same for Tumblebit, a fantastic mixing protocol that can be enabled right now if SegWit activates. But assuming it does, and assuming that Tumblebit goes live, also its privacy enhancements are based on the assumption that nobody's tracking the stuff that's going on and no one's storing data, which is kind of what we consider a weak privacy assumption. So some of these might solve privacy issues, but they don't solve fungibility issues, and that's really what we're trying to solve. Now, when it comes to solving fungibility issues, we need mandatory privacy, and the reason for that is, imagine you've got a hypothetical cryptocurrency that has 100,000 users, and we add a feature, which we call the magical cloud of privacy, and it's super magical, but only 1,000 users use it. The problem with this is that your anonymity set, as you move in and out of this magical cloud of privacy, is always going to be limited to 1,000 users at best. At worst, once you start adding in temporal analysis and those sort of things, you'll find that your actual anonymity set is much smaller. So mandatory privacy is the only way to really ensure that, that you have a large anonymity set, and the larger the anonymity set, the better. Now, when it comes to evaluating privacy technology, and this doesn't only apply to private cryptocurrencies, it applies to privacy technology in general, ideology is very important. And the reason that ideology is important is because the way you frame your development and the way contributors within a project frame their development is going to change and really affect the way they treat their code and the way they treat the things that they're doing. So using Monero as an example, Monero contributors are very aware that our code is responsible for securing people's money. At the very least, at a bare minimum, if we screw up, people are going to lose their lunch money. At the same time, no matter how many people I tell not to buy Monero, apparently people ignore me and buy Monero anyway. So we're also aware that we might be responsible or will be responsible for securing people's life savings. And the third thing is that we will probably be responsible at some point in keeping an innocent person out of jail. Well, someone we might assume or presume innocent, or someone we might view as innocent, but whose government doesn't view as innocent. And similarly, we might be responsible for somebody's life. And so a typical example is, if somebody had to go buy a Bible, do we have a problem with that? Well, generally speaking, we don't. They can go buy a Bible if they want to buy a Bible. But they might live in a country where that's banned. And if they use a cryptocurrency to buy that Bible, it might mean the difference between life or death for them. So any privacy-enhancing project that works with less care and less concern than we do is really disingenuous at best and irresponsible, and at worst is indistinguishable from a scam. Now, what Monero is and does, and it's important to understand the framing in order to understand why we've taken so many practical steps at enhancing our users' privacy.
Can I ask a question about the prior slide?
Yes.
So I agree that if we don't have something that's, if there's not a privacy layer, then it threatens fungibility, and that threatens the integrity of the whole system, and we haven't quite faced that probably in the scheme of digital currency so far. The thing I'm trying to ask myself is, is it possible that a system like Bitcoin or Ethereum, and zero knowledge proofs or whatever on Ethereum's roadmap as an example, introduce things that allow everyone to use privacy, and then there's some kind of bad event in the world using one of these digital currencies that makes it very apparent to everyone that this is really important. And now you sort of have one of these blockchains that's existed for quite some time with the history of all these coins or whatever, but let's say the majority of one of these networks by default starts using the privacy enhancing feature. Do you think that's a realistic scenario, or how do you think about that potential course of action?
So, I mean, yeah, look, I'm kind of a Bitcoin maximalist. So if Bitcoin had to add seriously good privacy in a way that was, I wouldn't, it doesn't even have to be mandatory, it just kind of has to be the default. And if that happened and there was tons of entropy in that system, great. Then yes, that would be fantastic. But two things. The first is, I've heard some really good arguments from some really clever people as to why Bitcoin needs to remain traceable, and I don't necessarily agree with their arguments, but those arguments are there, and those arguments might prevent this sort of thing from being added. The second thing is, in a system where it's not mandatory, even where it's the default, you basically end up with your OPSEC relying on the OPSEC of others. So you might end up being super private and super clever, and you send it to someone who's then lax, and it can be traced back to them, which means it can be traced back to you. So in a system where privacy is mandatory, it means that you don't really care if the person you're paying is lax, because they can't. There's no such thing. They can sort of do whatever they want, but to even dig down to them is hard enough. To then dig down further to you is a step removed.
Thanks.
Okay, so what Monero is and does. So with Monero, we take a four-step approach, or we've taken a four-step approach, and these things have sort of become apparent one at a time. The first thing that we use is dual key stealth addressing to basically remove the ability to see where a transaction is going to. We then use ring signatures to remove the ability to see where a transaction is coming from. We use ring confidential transactions to hide transaction values and make transactions cryptographically valueless. And then the third thing is we use I2P, and we have our own I2P router called Kovri that is C++ as opposed to the traditional Java router, and we use that to hide transaction originating IPs, so hiding it from passive surveillance. Now, a brief primer on how this works. If you're familiar with Bitcoin, and I assume everyone here is at least a little, you'll understand that with Bitcoin, you take your private key, from that you derive a public key, you generate an address, and then all outputs on the chain are visible, and you can see that an output is paid to the hash of that public address. Now, with Monero, where it's different is that we have two keys, and your address is literally your public spend key and your public view key, and then a output on the chain is not paid to those public keys in any visible way. It's paid to a random that's packed into a hash of those two public keys, such that it can be decoded by the recipient, but to anyone looking at the chain, it just looks like it's paid to some random number. So practically, what does that look like? So if we imagine a transaction where we have 1,000 Monero input, and we're paying 123 Monero to a recipient, each of those three outputs appears to go to a different recipient. It appears to go to a different address. Similarly, the change that's coming back to us appears to go to three different recipients. To anyone observing it, all they can see is that there are 6 outputs. They can't see who those outputs are going to. Now, when it comes to being untraceable, we use something called ring signatures, and the way this works is a single input in Monero, instead of coming from a single output in the chain, it appears to come from a number of old outputs, or old and new. And because you can't determine which of those outputs is the real spender or the real person who's making that transaction, it's impossible to determine where the transaction is coming from. You don't know if it's spending really old money or semi-old money or money that was recent. All you can see are these transaction inputs that appear to come from a number of places. So if we take this example of 1,000 Monero, we've gone and picked a bunch of outputs on the blockchain, and then what we do is we create a ring signature from a few of them, in this case from 6 of them, and that one in red is obviously the real transaction output that we're spending. The other ones aren't. And so, and then we create a key image, which is kind of like a hash of the spend of that real output to prevent double spending. But to anyone observing the blockchain, all they can see is that this 1,000 Monero input comes from one of 6 possible outputs on the blockchain. Doing this requires no interaction. It doesn't require any person to be online. You can do this entirely offline as long as you have a copy of the blockchain. And of course, the advantage here is the further you go down the wire and the deeper in the chain you go, the greater the anonymity set becomes, because one transaction comes from, let's say, 10, and those 10 then come from, another sort of 100, and the deeper down you go, the greater and greater it becomes, until eventually, maybe way down the chain, you can actually track it to a transaction that was deposited in an exchange. So because this anonymity set is so massive, and because a single output may appear to be spent multiple times over the history of the blockchain, it means that actually figuring out when it was really spent as an external observer is cryptographically unlikely. Now, with Ring CT, this is a system based on confidential transactions, which is in Blockstream's Elements project. And we took that idea and we basically built on top of it and created something called ring confidential transactions. And the way this works is instead of a destination paying an amount, It instead pays a cryptographic commitment. And a commitment is like a hash of a number or a way of revealing proof of a number without revealing the actual number. The cool thing about commitments is that cryptographically speaking, you can do mathematical operations on them, which means there's a way to verify and validate that you're not spending money that doesn't exist. So when it comes to actually spending an output, instead of spending an amount, you spend the commitment. And you sign a ring signature of the difference between the inputs and the pseudo outputs, and it's a whole complicated thing that basically means that you can't tell the amount of the input and you can't tell the amount of the output. Now, ring-CT is something that's live on testnet, and the hard fork on mainnet that's going to now make it an optional, a default but optional thing happens in like 4 days. And, and then after that, it's optional on mainnet, but in September of this year, it becomes mandatory with another hard fork. And then lastly, we have, yes?
Can you explain the key image again?
Sure. So the key image, just all there, I mean, on this page is fine. So basically, if you've got an output or an input that looks like it comes from 6 old transactions, you can repeatedly spend an old output, which would be bad. So the key image is kind of a hash of the signature. So if you try to spend it again in future, you're going to produce the same hash. And so then it will be rejected by nodes as a double spend. The key image is a little bit more complex than just a hash because there's also a way to validate that it's not just some random number you created, that it is definitely related to your real signature. So it's based on, I mean, if you look at the academia behind it, there was a white paper or the creation of ring signatures way back in 2001, and then after that someone came up with a way to do linkable ring signatures, and then after that someone came up with an improvement to do traceable ring signatures, and so this is really what it is. It's traceable, but it's not traceable in a way that can be decoded back to figure out who the actual signer is.
Can you clarify real quick how inputs are selected?
Sorry, how inputs are selected. So we use, initially we just had a Poisson distribution, so you just pick randomly on the blockchain, and they had to have the same denomination before ring-CT. With ring-CT, they don't. But now we've changed it a little bit, so we use a triangular distribution, which favors newer outputs, because people tend to spend outputs that are more recent, just by nature of, I've received money, now I'm spending it immediately. So we've done that, and then along with that, every single Monero transaction with the output selection, it will always pick one new output, like an output within the last 2 weeks, even if you're only spending old outputs. So it's it sort of balances the risk of I might be spending old outputs with I'm a new user who's definitely only going to be spending new outputs. But it is the distribution for most transactions is pretty random, and it doesn't really reveal much information because they all look like they're just randomly selected with the same system.
Sorry, maybe to combine those two questions then. The thing I don't get is, so you were saying the key image is effectively what prevents rather a double spend, because if you try to spend the same input again, you'll produce the same key image. The thing I don't understand about that is, since the inputs are randomized, it seems, couldn't you just have another set of randomized inputs where you still are taking your currently unspent output and trying to spend it again, but with other randomly selected inputs, and that would produce a different key image? Like, clearly that's wrong, but can you explain that?
Yeah, so the key image is based on your input and your signature on that input, not on the group signature as a whole. So it's not based on the aggregate.
So you can't back out. I mean, this is the thing about Bitcoin that is relatively intuitive, I suppose. You can see a transaction and, I believe, back out from that where the coins are coming from, basically. So here you can't do that, but you can still prove. Yeah.
Okay, so
I'm not fully understanding that.
You can see where, like, you could see those 6 transactions that it's coming from. You just don't know which one of those 6 is the real signer. So you cancel on the blockchain, you can view an input, and if you use like moneroblocks.info, you can go down to the inputs, hit the little plus button, and it'll show you the blocks at the block number and the public keys of all the participants in that input. You just can't tell which one is the real signer. And the key image is only, it's based on the real signer's signature, not based on the aggregate of all the signatures. So choosing different outputs in the blockchain won't change the key image.
But you can't tell that.
You can validate the key image.
Yeah. Okay.
So there's I mean, I don't want to
yeah, we can talk about it further offline. I don't want to take more time on it.
Nodes validate that the key image is definitely correct, and then they also validate that it hasn't been used before. Okay.
Ricardo, can you hear me?
So then, how do we resist passive surveillance? So this is something that we're working on at the moment. We use I2P as a layer, and it was a network layer. It's not the only network layer, and I'll explain that in a second. And the reason we chose I2P over Tor is for a number of reasons. The first is that we don't have to rely on Tor's directory servers. The second is that because of the symmetric design, I2P has a lot more routers. Every participant in the network is a router. And so you end up with a network that is a lot harder to analyze and infiltrate, even if you have a lot of participants trying to Sybil attack it. Now, what this looks like is, in the typical case, you will have a network where you might have several nodes who are naughty and they're logging. And what happens is they go, okay, this, when I broadcast my transaction, this is the first node that I saw this transaction from. And so that must be the originating IP address, at least in most cases. So what we've done is we've gone and built out this I2P router so that nodes will be connected on IPv4 to share blocks and on I2P to share transactions. And the net result is that when transactions are broadcast, they're broadcast over I2P instead of being broadcast over mainnet, or over ClearNet rather. And what ends up happening is those logging nodes can't tell the IPv4 address that it originated from, only the I2P address, which is pointless because I2P addresses are free to generate, so it doesn't link back to anything. And that's how we prevent passive surveillance. Now, Kovri is not complete yet. It does work, but there's still a lot of work to be done on it in order to get it to a point where it can be integrated into the Monero daemon. But that's something that we've been working on now for the past year and a bit. And it's starting to reach a point of maturity where we can actually release it. But yeah, it's just another one of those gaps that we're trying to close. Now, Monero's birth and growth is also something that's interesting because a lot of cryptocurrencies, especially nowadays, tend to be launched in quite a centralized manner. And so where Monero's birth is slightly different, or very different, is that we didn't launch Monero. Oh, wait, I'm not even there yet. Just before I even get there, we're not going to talk about price in this section because almost nobody in the community has cared for the past 3 years. So let's skip over the price thing. Everyone knows the price goes up, the price goes down. Nobody cares. Okay, so Monero's birth. So there was this guy called Thankful for Today that launched Monero. Yes.
Got a question from remote.
Sure.
Charlie Lee asks, since one can't tell an input is spent, doesn't that mean nodes have to hold on to every single UTXO in existence? How can that scale?
Yes, nodes have to hold on to every UTXO in existence. In fact, there's no concept of a UTXO. There's just a concept of a TXO. And at scale, well, I mean, UTXO growth in Bitcoin is unbounded. It just grows at a slower rate than Monero's because you have to keep the TXO set forever. The difference and the reason that it scales is the TXO set isn't kept in memory. It's kept on disk. So transaction verification doesn't require oodles of memory. And we've tested using on a sort of 2014 MacBook, I was getting 200 transactions a second for transaction verification. So it does scale reasonably well, at least in terms of that. In addition, a node can throw away blocks and only keep the TXO set in the key image set. And that's pruning, not down to the same level that Bitcoin prunes, but it's pruning down to a reasonably a reasonable level. So yeah, that's there is the ability to prune, just not like Bitcoin. At the end of the day, the only way we're going to grow this thing or scale Monero is by making mainnet always available for transactions, but using layer 2 solutions like Tumblebit and so on, and Mimblewimble, in order to provide scalability. So main chain will never be precluded or will never stop people from using main chain, but there's no point in making it the only possible way to scale. Okay, so getting back to Monero's birth. So this guy, Thankful for Today, launched Monero in April 2014, and initially it was just a fair launch of the CryptoNote reference implementation. And then he ended up being a giant douchebag and refused to listen to the community and insisted on Monero being merge mined, and after a whole big scandal with block voting where he set the default to yes, and then we changed it. Then eventually the votes were in, and like 93% of the community said, no, we don't want to be merge mined. And Thankful for Today went like, screw you guys, we're going to be merge mined anyway. And so that didn't play out very well. So myself and 6 other guys ended up forking Monero, or forking BitMonero at the time, into Monero. It was kind of weird because we didn't want an altcoin. It's not like we set out to launch an altcoin. We just ended up with this baby that had been put on our doorstep, and we were like, oh, damn. And we didn't really know what to do, but we knew that if we didn't run with it, that somebody else was going to run with it, and they were just going to screw it up. And we kind of figured we would be slightly less retarded than the next person, and so maybe it would be okay. And then we were committed, and we couldn't back out of it. And our role as the Monero core team, there's 7 of us, is just stewardship. You can't govern a network, a decentralized network, but you can govern a GitHub repository, and you can govern a domain, so that's what we do, in a sense. Now, we've seen incredible contributor growth with Monero over the past almost 3 years. The commits per month have increased drastically. And also the number of new contributors per month has increased. So we're just getting new people pitching up and working on Monero. And that's kind of cool, especially when you consider that all of this has happened over a period largely where the price was very depressed and where people weren't doing it because they thought they were going to get rich. They were doing it because they thought it's a cool project. And so we've ended up with a massive group of contributors, over 180 people that work on Monero, on various parts of Monero. And some of them include Howard Chu, who is the creator of LMDB and one of the masterminds behind OpenLDAP, and a whole bunch of other really cool people. We also have the Monero Research Lab, which are a bunch of academics that focus on, that focus on research and focus on the academic and theoretical part of things, and they publish papers. So, for example, quite early on in Monero's existence, we realized that not having mandatory privacy was a huge risk because it meant that an attacker can game the outputs, and if an attacker owns a certain number of outputs, then it snowballs, and eventually an attacker would be able to de-anonymize transactions just purely by owning a bunch of outputs on the chain. And so we made, there was a whole paper that we published that explained how we derived those statistics and why we needed to make privacy mandatory in Monero. We've also seen massive transactional growth, and this is transactions per week, and you can see that it spiked. It keeps spiking and it keeps growing. Obviously, a lot of the spikes are correlated to people buying on exchanges and withdrawing and that sort of thing. But what is really nice about this is after the September 2015 hard fork, all of those transactions were private by default. You couldn't turn that privacy off. So it means that the bulk of the outputs on the chain are all private. And that creates a massive, massive anonymity set that you can easily get lost in. And we've also seen massive community growth because, again, you see these spikes in transaction volume and you go, well, it's people buying on exchanges, it's speculators, that's all they're doing. But when you see the increase in people that are interested in Monero and you see real world usage, then it's sort of confirmation that what we're seeing is not just speculators, but people actually using Monero. And we've had sustained subreddit subscriber growth, regardless of the price increase and that sort of thing, or even press coverage. And now, I mean, we're trying to make Monero useful and usable, because it's kind of pointless having this thing that we work so hard on, and then it's super complicated to use. And I mean, to that end, we have been like CLI only for a very long time, and we only released the Monero GUI in December, but there have been third-party GUIs over the period, and there's a web wallet that I run, which people keep getting money stolen off of, but it's another story. So some of the things that we've done with Monero in order to make it useful and usable is we have a dynamic block limit. So we don't have a fixed cap. We have a flex cap-like limit that increases based on usage. So there's a median, and then miners can push slightly above the median without getting punished. If they push too high above the median, they lose block reward. And so that median slowly increases as there is demand. And we've coupled that with a dynamic fee system. So as Monero is more used, we work on the assumption that greater usage and greater demand will mean an increase in price, and therefore people will want to pay less fees. So that the fee scale with an inverse proportion to that. We have a disconnected architecture, so the daemon runs separately from wallet clients. And you can, within, say, an office or a home environment, have one machine, and that's the node, and that syncs up to the Monero network, and then have a bunch of wallets sitting behind it, scattered all over the network. As opposed to Bitcoin's current architecture and the architecture that most coins have inherited, which is wallet and node are one. And then we have OpenAlias, which is an aliasing scheme. It's DNSSEC secured, and it also works with Namecoin. And basically, the net effect of OpenAlias is that you can set up an alias on a domain that you own, and you can send payments to rick@spagni.net or donate.getmonero.org. And then, obviously, it goes and checks that over DNS and checks that the DNSSEC signature is valid. And that's how it ensures that somebody hasn't gone and tampered with the record. And then we have an accessible proof of work algorithm. So instead of, or we hope to sort of avoid the clustering issue that a lot of coins see. And this proof of work algorithm isn't ASIC proof because there's no such thing. But what it does do is reduce the performance gap between CPUs, GPUs, and ASICs. So even though GPUs are quite dominant in the mining network right now, CPUs are still fine. And there are a lot of people that mine quite well with CPUs. Presumably botnets and that sort of thing. So the core Monero GUI that we released in beta form in December took us quite a while to get right because we didn't want to just slap some lipstick on a pig and off you go. And we started off with wireframes and created a whole bunch of elements. And in the end, it ended up looking quite nice and is quite functional and is worth a download if you want to play with it. And then, of course, we have the view key, which is interesting from a regulatory perspective, because the view key is it's sort of like an opt-in regulatory element. So it basically allows somebody to see all your incoming transactions. And that's really useful for things like allowing a node to remotely or to scan your transactions and then only give you the ones that are relevant to you. But it's also useful for things like charities that can publish their view key, and then it's easy to confirm that the amounts that they claim to have received are indeed the amounts that they've received. Similarly, an auditor can be given your view key, and then he's able to confirm the amounts that you've received without being able to spend them. And then obviously, there is the possibility that in a scenario where law enforcement wants information on your Monero accounts, they could just come knock on your door and say, please give me your view key. We also have a scheme that we've been playing around with, which would allow a view key to be coupled with a nonce that would then also reveal your outgoing payments, not just your incoming payments. And ultimately, from a regulatory perspective, we have seen things like Kraken, who've added Monero and haven't been shy about talking about Monero's privacy and fungibility enhancements. And something else that happened, which was kind of surprising to us, was last year, Apple asked JAX to remove Dash from their iOS application. And we immediately thought, okay, it's because of Dash's claim to have private transactions, and so Apple obviously don't want bad things happening on the iPhone. And then, like a month later, or whatever, a couple of months later, Jack said, well, no, Monero is fine. Apple said it's fine. So that was kind of confusing because it appears that Apple have done whatever research they've done and decided that Monero is fine from a regulatory perspective, and Dash is not. Now, I don't know why they've decided on that, but it is kind of cool to get the thumbs up from Apple. Not that we have a wallet on the iPhone, but at least somebody would be able to build that out. The future of Monero, well, there's a whole bunch of things that we're trying to build because Monero is functional as a base layer, and there's a lot of cool stuff that we're adding to Monero, but ultimately we want to use it as a base layer to build things out on top of it. Besides transactional privacy, there are a whole bunch of things that we want to do, like micropayments, like systems for identity and trust, like systems for tradable assets, and then also allowing projects like Counterparty to anchor into the Monero chain. And these are all things that given the open source decentralized nature of Monero, will probably take us like 10 years, but at least they're kind of on the radar. And that's about it. Thank you very much.
So one thing we were thinking about the other day was, if we were going to list Monero on Coinbase or GDAX, how could we meet our regulatory obligations about transaction monitoring and everything? And we thought about the view key. I was just curious what you think about that. Is that a good solution? Like if someone's going to do a send from their Coinbase wallet and we want to demonstrate that we're meeting our transaction monitoring obligations, could we just ask them for the view key in that scenario? And what do you think the implications of that are?
So I guess the problem would be if they're sending it to a wallet that's under their control, sure. You can say to them, please give us your view key. If they're sending it to a wallet like they're moving coins from GDAX to Poloniex, you can't really go and ask Poloniex. Well, I mean, you can ask Poloniex for their view key, but I don't know if they give it to you. But I mean, that would kind of, it would be tough because you'd probably have to have something in place where people can only withdraw, or you state that people can only withdraw to wallets that they control so that they can give you the view key. And you can confirm that they are in control of the wallet because here's the view key, you see your withdrawal going there, and so there we go. I think that would probably be the best way to do it.
Okay, so the view key comes from the recipient address. It's not from the sending action.
Yeah, so I mean, your wallet would have a view key, and you would see all the deposits in with that. But yeah, they would need to provide the view key for the recipient wallet.
Okay.
Yes.
I'm curious if, let's say, a regulatory environment comes about where view keys are provided pretty actively and readily. Would there be a possibility of essentially creating enough tainting to be able to triangulate transactions at some point in time?
Yeah, so that's one of the concerns with a scenario where, let's say, Monero became massively used in a country, let's say the US, and then the IRS mandated that everyone had to give out their view keys or hand over their view keys, and then the IRS ended up with a collection of view keys. They would be able to use those to de-anonymize certain transactions because they would know, they'd be able to identify a bunch of outputs. It's a little bit more complex than that, but at its core, yes, anyone with a very large collection of view keys that owns a large number of outputs is in a position of power in terms of de-anonymization. There's one of the Monero Research Lab publications, MRL1, goes into detail about what percentage of outputs on the chain an attacker would need to identify in order to de-anonymize transactions, and it's pretty high. I mean, to really have any sort of effectiveness, they'd need to own like 80% of the outputs on the chain. And the other thing that could happen is we could blacklist outputs. So we could say, okay, well, yes, everyone that's publicly submitting or that's submitting their view key to the IRS can also just pop it in some system, and then we blacklist outputs and we don't mix with them. So it's there are many ways to get around that scenario as and when it occurs. And given the large number of outputs in the chain, I don't think we'll ever want for outputs to mix with.
Thank you.
So it sounds like you don't really want like an altcoin, but you like, or Monero's main use cases are as a private payment network and stuff. What is your view kind of altcoins and Monero's future, given that it is its own currency right now?
So, yeah, it's, like we didn't want an altcoin at the beginning. I mean, we've kind of grown to love Monero as our red-headed stepchild. I think, like at the very least, my view of altcoins in general is pretty grim. And I think a large number of them are either scams or just poorly designed and badly implemented. It's really hard, and I speak from personal experience now, it's really hard to create decentralized security software that isn't full of stupidity. I come up with stupid ideas all the time, and thankfully there are enough people involved with Monero that they can shoot my stupid ideas down. And because of that, I think that we're going to see scenarios where any altcoin that grows to a certain size and has a bunch of really badly designed features will end up getting attacked and broken and whatever. In terms of my view of Monero itself, I've resigned myself to Monero's existence at the least, and I'm excited about Monero. I do love Monero. I'm also, my view of it honestly, in relation to Bitcoin, is that at the very least it presents a hedge against things like Bitcoin's EC curve being found to be bad. And in which case, it's not that the EC curve couldn't be changed, it's just that during that time, the amount of damage that could be done would be substantial. And at least Monero would exist as a safe haven. Yes.
So this is sort of going back to Charlie's question earlier, but so in Monero, is it correct that you can't determine if a specific output has been spent?
Yeah, you can't, yeah.
Is that correct? Okay, so that means that all nodes have to store all outputs for all of time? Okay, and then that means you need, so as a node, you're storing all outputs for all time. Then you need to look up a given output to like verify some future transaction as a node, correct?
Yeah, you need to verify that the output exists,
yeah,
and that the key image hasn't been spent. So those are the two things you need to keep: is the TXO set and the key image set.
Right. So what's the lookup time? Like, so this thing is growing forever for all of time, right? What's the lookup time then to look up a prior output for the purposes of verifying a new transaction, if this thing is just like, if that set of outputs is just growing and growing and growing?
So we store, the way we store it on disk is we have a denormalized index for transaction outputs and for key images. So that was the thing I was talking about earlier, where on my 2014 MacBook, I was doing 200 transactions a second with the blockchain in its current size and with the number of outputs in the blockchain. So yeah, presumably as it grows, that seek time increases because the denormalized tables increase, but so too does disk speed increase and access time decrease.
So, okay, so the lookup time is like O of log n or something like that?
Yeah, and given the way we're storing tables and given because it really does come down to practically how are we doing this. And that's why we've been kind of grateful that Howard Chu has spent a lot of time optimizing LMDB and the way we use it. So yeah, I think, if we were storing it in memory, it would be a harder problem to solve because we'd end up hitting growth, uncontrolled growth that would basically make it infeasible to run a node. If you need to have like 32 gigs of RAM to run a node, it becomes kind of chunky.
Right.
But at the moment, it's just fine, even on spinning disks.
Right. right? But those are two different limits, right? One is how much can you load into memory. The other is just like, what's the lookup time to look up any prior unspent output. And it seems like if Monero is really successful, and by the way, one caveat on this, like I love that you guys are like working on this and it's like a hedge and another thing that's being done in the community. So like, let me state that before I just like ask all these like annoying questions or whatever. Yeah, so that means that like if Monero is successful, especially with the splitting thing that you described, then the list of unspent outputs is just going to like grow exponentially, basically, right? So you can do optimizations, and theoretically there will be advances in hardware that make lookup times better and all that stuff too. But ultimately, if it's a O of log n thing, it seems like you can't exponentially decrease the like hardware speed or the lookup to optimization to match the exponential growth in unspent outputs. How do you think about that?
Look, I mean, so there are a couple of things. The first is with transactions prior to ring CT. They created a lot of outputs because they needed to split into power of 10 denominations in order to create mixable sets. With ring CT, you only need to create one output for the recipient and one output for change. So transactions are going to create less outputs than they did previously. So that's an optimization, a sort of unexpected optimization that we're gaining, in that transactions are creating fewer outputs. You are correct that the output growth, or the growth in the output set size, will be rather rapid if it gains any sort of real world use. The flip side to that is, I mean, at the end of the day, if we're building out layer 2 systems at some point in the next few years, and people are primarily using layer 2 systems and settling back to main chain, then like the growth will be really in those layer 2 systems, and main chain's growth will be stunted by comparison.
Okay, so you'd hope for something like Lightning, but Monero equivalent or something.
Because honestly, I mean, if we had to scale to a point where we've got like, I don't know, 200 meg blocks, that's infeasible. You know, you're going to end up with a scenario where you need to run on like NVMe disks in a data center.
Okay. I got another question from Charlie Lee here. So you heard that there was a bug recently with Ring CT that had a bug in the range proofs. Can you elaborate on that? And what do you think the risks are that something similar will be found in the wild and cause people to lose a lot of money?
Yeah, so the bug was that we weren't committing all the things. So the way we were doing ML-SAGs was to commit. Basically there were certain pieces of data that weren't being committed as part of the commitment, and that ended up being an exploitable flaw, where you could effectively create create an output not out of thin air, but fake an output value. And that's obviously kind of pretty bad. You know, it's like not ideal. But yeah, that's obviously solved. The way we're doing it now with borrow-mean signatures is the same, like roughly the same way that confidential transactions does it. So there's a lot of security in that. Excuse me, a lot of safety in the fact that confidential transactions has been reviewed. And we've also had Ring CT reviewed as part of Ledger. It was in issue 1 of Ledger. At the end of the day, it doesn't really matter what you do. You can always end up with some 15-year-old kid coming along and saying, oh, look, I just broke everything. And that's a systemic risk with something like this. It's a systemic risk with any cryptography. And that's why we kind of, we aim to use cryptography that is older and more well-known. And at the end of the day, you've got a scenario where you have as many eyes as you can have on the work that you do, not only from a the academic and research perspective, but also in the actual implementation. If we do screw up, and we screw up badly, then like that's on us. You know, that's something that we're going to have to live with. And I'm hoping that we haven't, and I'm hoping that the broad base of contributors has done their part to make sure that things are okay. And we've had a lot of people and a lot of attackers poking at Monero. I mean, in September 2014, an attacker managed to fork the chain in a really ugly way, because the tree chain algorithm that was basically used to compute Merkle tree hashes within a block started using uninitialized memory after 512 transactions. And so they just had to create a block with more than 512 transactions, and then nodes were unable to verify it because the miner that created it, obviously, transaction number 513 and 514 had a different hash to everyone else. And that was really messy, and we've ended up having to put in a blob hash for that one block, because there is no way to recreate that block in any meaningful way. And so everyone just has to sort of trust that that block is okay, and that we all agree that this is the hash for the Merkle tree hash for those two transactions. And having like those sort of attacks early on helped us to have a fair degree of rigor and a fair degree of care with a lot of the stuff that we've implemented. So all we can do is our best and hope that we haven't royally screwed up.
Does Monero support scripting or no?
No, we've got a very lightweight scripting language that does like very little. At the moment, we're busy working on multisig because we don't have multisig, and that's sort of something that we're poking away at. I don't think we'll implement a scripting language just purely because it adds complexity that we can't really afford to play around with right now. And I think there's a lot of stuff that we can do without needing a scripting language. But I mean, yeah, maybe if in future they will find need for it.
And with the sort of fair proof of work or more equal proof of work, can you just talk about kind of who's mining, and is it even possible to see who's mining on the network, or how view how centralized mining is or anything like that?
Yeah, look, I mean, it does cluster to pools. I mean, that's sort of the nature of the beast. You know, professional miners are too lazy to set up their own pool or whatever. I mean, the pool distribution is reasonable. We've also got something that we're working on called background mining, where nodes will be able to, or not even nodes, but just people will be able to mine in the background when their computer is idle and plugged into power, and it'll mine to a threshold so it doesn't crash their CPU. And that'll be on by default in the GUI and so on. So people, I mean, they'll be able to opt out of it during the wizard, but we're hoping that will provide enough of a chunk that we won't really end up with a scenario where any single pool can even get over 50%, given the presence of other pools and background mining and so on. We're also kind of fortunate that we have a couple of botnets mining Monero. And it's, you know, like normally that's not something that you say, but it is good because the botnets honestly don't care about pools. They're on their own private pools. They're always up to date because they don't want to lose money. And you know, they represent a substantial chunk. They represent like 20-30% of the hashing network. And like they're not malicious. I mean, they're malicious to the people's computers they're mining on, but they're not malicious to Monero. They're securing the network. So, you know, it's kind of like, how do you stop them? You know, you're sort of like, well, thank you for securing the network. Please, can you not do that?
Yeah, how you think about things like proof of stake or you know, a more complete scripting language? Like, are those things that you think are like you potentially consider adding at some point, or those like are outside of the scope of Monero, or yeah?
Okay, so I'm of the opinion that proof of stake is unworkable for a number of reasons, but the explanation that makes the most sense in my head is that in order to attack proof of stake or proof of work, you have an upfront cost. You either need to acquire a bunch of stake or you need to acquire a bunch of equipment to mine. The difference is from that point on, you can attack a proof of stake chain for free. You can attack it on a Raspberry Pi, whereas with proof of work, you have to pay electricity the whole time as long as you're attacking. And I think the difference between those two alone means that proof of work is substantially more secure, regardless of any trick you add to proof of stake. And unfortunately, a lot of the a lot of the schemes that are being suggested are just silly little tricks, trying to add complexity in order to reduce attack surfaces. And complexity, unfortunately, especially there, is the enemy of good security. Any complexity is, but especially in that space where it becomes quite so sensitive. In terms of like Turing complete scripting and that sort of thing, I mean, it's definitely outside of the scope of Monero main chain itself. If somebody wanted to build something like that on top of Monero, it's not like we'd stop them. But I think given what we've seen happen with Ethereum, I'm not convinced that adding that attack surface to anything is a fantastic idea. Definitely not in a way that would put the entire network at risk. If it's a system built on top of it and that system goes down, well, you know, that's that system's problem. But in a way that could that could affect the network, that's not great.
Okay, thanks. What will it?
Well, we're pretty much out of time, but Riccardo's going to be hanging around for lunch, so feel free to ask him questions directly.
Cool.
Thank you.
You.